all of you, welcome for this video. So here we'll know what are the properties of the bar element in FEM. So before solving the any problems on the problems, you can say, so you should know their properties of the bar element. So in generally 1D bar element we'll use to say in the FEM, one dimensional bar element. So when we can say it's a bar element, for example, if you are having one shaft with x distance and x diameter, so here if this is one shaft or one rod, we can say here if the load is applied, for example for this shaft, if you apply the loads along the axis, so this is the neutral axis for this element. If the loads are applied along the axis, then we used to say it's a bar element. But if the same shaft, if the loads are applied perpendicular to the axis, then it will be termed as a beam. Okay, so that is the difference between bar and beam. Now here in this video I am explaining about the bar element. So what are the properties of the bar element? Okay, so here, okay, this will be a bar element. So now about the geometry. First consider about the geometry. Here we are assuming this bar element is a geometrically straight. Okay, that is the first point you have to consider. It should be geometrically straight. And coming to the material for this element, okay, whatever the materials are used, it may be aluminum, steel or any material, but that should be obeys the Hooke's law. It means the stress should be directly proportional to the strain within the elastic limit. Okay, within the elastic limit it should obeys. It means generally it should be a structural member or structural properties. Okay, such elements will be considered as a bar element. Now about the loading condition, as already in the starting I explained about the loading condition, but for bar elements it is to be assumed to be supposed to be axial loaded. Okay, axial loaded means the loads which are applied along the axis, which I already explained. The loads are applying along the end of the bar or at the middle of the bar, anywhere that should be along the axis, and also can be any type of load. It can be tensile load or it can be compressive load, but it should be axial loading condition only. Okay, now the axis. Now this axis for this elements having only one axis, okay, for the entire the bar axis, and which is same as the neutral axis. This axis will be called as neutral axis. Okay, same thing will be applied in the beam element also. It will also having the neutral axis. Okay, and about another points, the degree of freedoms. Okay, so each nodes or each node they will be having single degree of, for example here there is a load, so here the load will be having a node and it will be along the axis. The load always it will be considered as along the axis. Okay, that's the only one each node in the bar element, and also at each node there will be one force. At each node there will be one force. For example, node 1 there will be F1 and U1. Okay, F is the force applied and U is the displacement or deformation. And this bar element can also be a spring element. Okay, so if it is a linear spring, for example, if you say this is a one linear spring and having two nodes, so this linear bar element, it can be identically a spring element also, except that the stiffness in the spring element, it will be taken as directly. Okay, in bar element it will be given as A, E or L is required for this. For the entire stiffness will be directly given for the spring element. Okay, other than that both will be identically same. Okay, both will be considered as same. In case of bar element, take as A, E by L is the formula for stiffness. So here where K will be directly given in the spring element. That is the difference. It's not a difference, both are same. Okay, K will be directly given in the spring problem. That is the that you have to understand. So this is about the properties of bar element. Some of the properties I have explained, but it may be having many, like it may be limitation and also the use applications, everything will be covered in this, so that you can go through. Okay, these are very important to understand before solving any bar element, because here how to make the nodes and what are the materials are required and what are the elements. So generally bar element we also called as, it's a what is called a linear element. Okay, linear means it's a straight along the axis. So which type of linear element you have to select in the analysis, so all this you have to go through before selection of the materials. Okay, so thank you for watching this video. Have a good day.